Testing, 1, 2, 3. It's working. Okay. So trigonometry means triangle measure. Okay, and a lot of like higher level mathematics is based off trigonometry. So when you get to pre-calculus, first semester is all trigonometry. Okay, which is all about measurements of triangles. So you use trigonometry to figure out things about the unit circle and do sine curves and cosine curves, and from there you go to all kinds of different trig functions, and there's, then they do calculus with trigonometry. So it's really the basis for all this is just triangle measurement. What was I going to do? I was going to how did I get off on that topic? Oh, I don't know. So anyway, say you have a bunch of similar triangles. So say this triangle has these sides 3 to 5, and say this one is like twice as big and 6 to 10, and say this one's 3 times as big, so let's make this one 9 to 15. Oh, come on. Please don't do that on me. Okay? So say this triangle is in the ratio 1 to 3. Okay? What would always be true about this angle right here? It's going to be the same here, here, and here, right? Because in similar triangles, all the corresponding angles are congruent. Well, it turns out I could take my protractor and I could put it on that angle. Oh, maybe we should even try to do that. Where's a protractor? I have tools. Here we go. Protractor, protractor, protractor. Watch this. Protractor, protractor. You know, my wife and I, we like to go to the protractor races on the weekends. Anyway, so protractor races. Yeah. But I could take this, I could measure this angle right here in this, see this angle right here? I'm going to measure that angle right there. How do I measure that angle? I come over here, I put my protractor here. Can I swing this thing? This is, I can measure, well, that angle if I put my protractor right here, that angle appears to be, I don't think that's lined up quite right. Whoa, is that cool? Oh, that's how I do it. So let me try that again. Okay, so I'm going to take this, put it, I guess I could drag this. I can't. And that angle, oh, it's in radians. Oh, 149 degrees. Well, it's not because I'm going from the wrong side, right? So it's actually, if I move it over here, it says it's about 151 degrees from here to here. So it would be, what, like 29 degrees or something like that? About 29 degrees. So if I took this and I measured this angle, okay, I would get that angle is approximately 29 degrees. Would this angle also be about 29 degrees? Yes. Yeah, so all through 29 degrees, 29 degrees. So what people did a long time ago, they said, well, when I have an angle that has, when I have a triangle that any triangle that is similar to this triangle is always going to have an angle there of approximately 29 degrees. I think I measured it wrong, but turns out that they call that the tangent ratio, okay? The tangent of 29 degrees is going to be approximately equal to 3 over 5, which is what? What's 3 over 5? It comes out to be a decimal. What do you get as a decimal? It's exactly 0.6. So I'm not sure if I measured that right. Maybe it'd be better if I measured it on this one. Okay? It still looks like about 29 degrees. So now, if I take a calculator, okay? Calculator, here's a calculator. That's not a calculator, that's not a calculator. Let's get a calculator. Okay, here's a nice calculator that looks like some of the calculators that you have. Go, go, go. Go, go, go. I don't need that protractor right now. Okay? Go away. And the other thing, when you are doing these trigonometry problems, this has a mode key. Where's the mode key on this calculator? Mode. Oh, right here, okay? You have to make sure that you're in degree, because some of you will get wrong answers and you go, what's going on with my calculator? I'm getting all the wrong answers. You have to make sure that you're in degree mode. Radian is another way to measure angles, okay? And so there's like 57 degrees or something like that in 1 radian. We're not going to worry about it. So make sure when you're using your calculator for all of these that you are in degree mode, okay? You always in front. Okay, so I'm going to close this. So now if I go second quit and I go to the tangent, let's clear that out, and I go to the tangent of 29 like this, okay? And I hit enter, I get an error. I messed up, okay? Let's try that again. Tangent, second quit, clear, sorry. Clear. Okay. Oh, I have too many parentheses. Delete that. And if I hit enter, I get about 0.55. So I should have gotten about 0.6, right? But I probably measured that angle. I'm off a little bit on the measurement of that angle, right, when I measured. But, so what does that mean? That means, okay, going back to our picture over here, what that means is that when this ratio is about 0.6, this angle over here is going to be 29 degrees, okay? So you could use that to solve, you could, and what someone did a long time ago is I'm not exactly sure of the algorithm that they used to figure this out, but they said, okay, when this ratio is 6 to 10 or 3 to 5, this angle is always going to be something. And they computed this table down to the 10,000ths place. In your calculator, it goes even further than that. But when I was in high school, we used to have something called trig tables, and they would have a table and they'd have this angle, and then they give you the ratio of the tangent, the sine, and the cosine, and you'd have to go flip to the back of the book and figure out, okay, what is the tangent 29 degrees, and you would look it up in the table. It was like 29.1, then you had to move over a little bit more or less and use a process called extrapolation where you're using ratios to figure it out. I remember doing that. But what's nice about that, say you know that this angle is 29 degrees, okay, and you know that this side is like 55 meters or something like that, and I want to find out what this side is over here, x. How could I do that? How could I set up an equation to find that side x? Exactly. You know that the tangent of 29 degrees, right? Tangent of 29, which is approximately equal to, what we just say, about 0.554, okay? Which is about equal to 0.554, is going to be equal to this side divided by this side, right? The opposite side divided by, that's called the adjacent side. And then you just, whoops, why did I put 5 there? Sorry. I'm just going to put x there. How do I get x? How do I get x? If 0.55 is equal to x over 55, how do I find x? Multiply, right? So x is going to be equal to 55 times approximately 0.554. And so I'm going to multiply that times 55. And I get that this, if this were like the height of a tree or something, what did I just say? It's about 30.5, about 30.5 meters, right? Yes? No? Maybe. Okay. So that's what's kind of cool is with a right triangle, so this only works for right triangles, okay? So someone figured out what the tangent ratio is for right triangles given no matter what the lengths of those two sides are, okay? So let me draw another. I know it'll solidify in your brain in a little bit. Okay, so say I were to draw another triangle, and I call this angle A over here. This from angle A in a right triangle, this is called the what of a right triangle? This is called the hypotenuse. Okay, you know that, right? That's the longest side. Also the side opposite the 90-degree angle. From A, this is called the opposite side. Opposite side. And from A, this is called the adjacent side. Adjacent means next to, you know that, right? So what someone figured out is they said, okay, we're going to have 3 different ratios. The first ratio is called tangent, okay? And tangent ratio is equal to the opposite side over the adjacent side. And we kind of abbreviate it with 3 letters. Tangent ratio is equal to the opposite side over the adjacent side. So the adjacent side is the hypotenuse is also adjacent to A, but the hypotenuse is the hypotenuse, okay? It's by itself, so the one that's next to the angle that's not the hypotenuse is called the adjacent side. Then they said, okay, let's also, what if I want to know if I have this side and this side, okay? So with a right triangle, use a Pythagorean theorem, if I know this side and this side, how could I find this side? How could I find that side? If I know 2 sides of a right triangle, how could I find the third side? By the Pythagorean theorem. So I could find this side if I wanted to, but they said, oh, I don't want to do the Pythagorean theorem every time. Let's figure out another ratio, and we'll call that, I should not write the abbreviated form. They called that cosine, okay? I'm not sure why. Cosine, and cosine is equal to, anyone know what cosine is equal to? It's equal to the adjacent side, ADJ, divided by the hypotenuse. And then, so if I know, so here's the adjacent side, divided by the hypotenuse, and that has a certain ratio. And then I have the sine ratio, okay, sine, and that's equal to the opposite side over the hypotenuse, okay? And so what these people did years ago, they said, okay, when this ratio is this over this, then we'll call that cosine, okay? And when this ratio is this over this, we'll call that tangent. And this angle has a certain measure given those certain ratios. Sometimes we abbreviate this with so, ka, toa. You should probably know how to spell that. Have you seen that? So have you ever heard of that? SOHCAHTOA stands for sine is equal to opposite over hypotenuse. HYP. Cosine is equal to adjacent over hypotenuse. And tangent is equal to the opposite side over the adjacent side. Okay. Okay, and depending where you stand, where you're standing, or which angle you're talking about, those things change. So if I call this angle B up here, what is now the opposite side? Where's the opposite side from angle B? It's this side over here, right? So if I'm talking about, so if I'm standing at angle B, okay, then this is the opposite side and this is the adjacent side. Hypotenuse is always a hypotenuse is always a hypotenuse. You don't ever stand at angle C. Don't worry about angle C, okay? Because then we don't really have ratios that work with that one. So if I'm at B or I'm at A, the opposite side and the adjacent side change. The reason one is called sine and one is called cosine, what's the sine of angle A? Well, let's do another one. I'm going to draw another picture. Okay, so there's another picture, So here's a picture. Here's angle A. We'll call this angle A. We'll call this angle B. We'll call this angle C. We'll call this the right angle. So notice what they do a lot is if this is angle A, they call the side opposite angle A little a. And if this is angle B, they call the side opposite B little b. And if this is angle C, they call the side opposite, that should be a C, not an E. They call the side opposite angle C little c. Okay? So what's the sine of angle A? Who can tell me what the sine of angle A is? What's the opposite side over the hypotenuse side? What letters? Opposite side over C. What's the cosine of angle A? What's a cosine of angle A? What's a cosine of angle A, Ian? Give me your phone. Thanks. You gotta pay attention. There's math going on. Put it in your bag, okay? Put it away. Okay? It's B over C, right? Adjacent over hypotenuse. What's the tangent? Oh, stop. What's the tangent of A? Tangent of A. A over B, right? Now I'm going to stand at B, okay? What's the sine of B? Tell me the sine of B. What's the sine of B? Hannah, what's the sine of B? Where's the opposite side from B? What letter is opposite B? B, yes. Over C, right? B, opposite over hypotenuse. What's the cosine of angle B?
B over A.
No, A over C, adjacent over hypotenuse, right? A over C. And what's the tangent of angle B?
B over C.
Opposite over adjacent, B over A, okay? So notice one is called sine and one is called cosine. Notice that the sine of angle A is equal to the cosine of angle B. See that? And the cosine of angle A is equal to the sine of angle B. See that? Okay, they're both equal to B over C and A over C. That's why they're called co-functions, okay? Because the sine of one is equal. We do have a cotangent, but we're not going to throw that. Cotangent of A would be equal to the tangent of B and so on, but we're not going to talk about those. Okay? So big deal. Who cares? I care. How do you use these to solve problems? Okay? So I already did a problem with a tree, but we could do a different type of problem. So say I have a problem like this. Another triangle. All these are going to be right triangles. Okay. Here is, all you know is that this angle is 21 degrees. Okay. And this is a right angle. And I know that this is, here's an airplane flying up here. Airplane. All right, good airplane drawer. Okay. And you look up your airplane and you notice from your eyeball up to that airplane, it is, there's a 21 degree angle. You want to know how far it is, how long this thing is, right? And so we'll call this X. And you can measure the distance from here to, I don't know, the point that the airplane is on top of. and I want to know how far that is. So you have to figure out which of my three trig functions am I going to use based on that picture. Okay? So which side do I have here? This is the, in regards to this angle right here, this 21-degree angle, which we'll call angle A, which side is this and which side is this? I have adjacent and hypotenuse. Which one of my three trig functions? Cosine. Okay? So what I write is that the cosine, and I abbreviate cosine COS, of 21 degrees is equal to x, no, that's wrong, is equal to adjacent, right, which is 100 divided by the hypotenuse, which is x. Yeah? Okay? How do I get x by itself? You multiply both sides by x, and you divide both sides by cosine. Cosine, you can't just divide away, you can't separate the cosine from the 21, right? So what you have to do is I have to multiply both sides by x, basically, okay? And divide both sides by the cosine of 21, okay? By the cosine of 21. And then I get, this goes away, and this goes away, and I get x is equal to 100 divided by the cosine of 21 degrees. Yeah?
Yes.
No? There's an easy math trick. Watch. If I know that cosine of 21 is equal to 100 over x, you can just switch places with these two things, okay? It's mathematically legal to just interchange, bring the x over there, and write this as 100 over the cosine of 20. It's a lot easier than doing all this ugly math, right? So if the x is on the bottom, like this, just switch places with this and this. Basically, you're multiplying both sides by x and dividing both sides by cosine of 21, okay? So now I could do the math. I could take my calculator, and I could take 100 and divide it by the cosine of 21 degrees, okay? And I hit enter, and now I know that this is about 107.1 feet or something like that. Easy enough? Pretty, it's kind of fun, okay? You want to try one? Here, you're going to try one. You try. You try. You try. Everyone has a scientific calculator?
Yeah.
Everyone has a scientific. You need to have a scientific calculator. It needs to be in degree mode. That's not the picture I want. That's not the. This is the picture I want. Okay. Whoops. So say I know that this angle is 58 degrees up here. 58 degrees. Here's x, and here's 15. And this is your right angle. Find x. Find x. I'm going to pause for station identification.
1.8.
Because I got 1.82 because I was in radian mode. And then I changed it to degree mode, and then I got the right answer. Okay? So yeah, if you got 1.8, you're in the wrong mode. Okay? So you have to make sure that you're in degree mode for these. So make sure of that. Okay? And then you would know, you write tangent of 58 degrees is equal to 15 over x. All right? And then I can switch places. I get x is equal to 15 divided by the tangent of 58, right? And then I could take my calculator and I could say 15 divided by the tangent of 58. And I get that length is about 9.37, okay? Now another thing I could have done, I could have found this angle first. What's that angle? What's that angle? If this is 58 and this is 90, what does this angle have to be? 32, right? Because those two have to have 90. So the other thing I could have done is I could have said that the tangent of 32, right, is equal to x over 15. How do I get x by itself? Just cross multiply, right? Just multiply both sides by 15. So in that case, I get x is equal to 15 times the tangent of 32, right? Let's see if we get the same answer. 15 tangent of 32. Same exact answer. See that? 9.37. Could have done it either way. What? If I found this angle here, right, then I have opposite over adjacent, right? X over 15. Okay. I don't think you have that quite mastered yet, do you? No. So, what if, now we're going to get you really messed up, okay? What if instead of wanting to find a side of a triangle, I want to find an angle. Here's a triangle. I'm going to take this triangle. I'm going to turn it around to make it confusing. There's a triangle. That's not very confusing. But say I know that this side, here's a 90-degree angle. So I know that this side is 12. And this side is 10. And I want to know what this angle over here is. Find angle, we'll call it theta. A lot of times they use theta to find Greek letters to find angles. What trig ratio am I going to use? What side, from angle theta, what side is this? That's the what side? Opposite, adjacent, or hypotenuse? Opposite. Okay? And this side is the hypotenuse. So I have an opposite side, and I have a hypotenuse. Which trig function uses opposite and hypotenuse? Sine. Sin. Yes, that's right. It's a sin. So you say that sine of theta is equal to opposite over hypotenuse. So sine of theta, in this case, we call it sin instead of sine just for abbreviation, is equal to 10 over 12. Now you could reduce that and change it to 5 over 6. Anyone know how I find out what that angle is? The people who made the trig tables, they went through and they calculated all this stuff, or they used a complicated algorithm, but they figured out what this angle is when this ratio is 5 to 6, okay? And the way you do that is you use the second sign button, okay? It's called the inverse sign. So see the little sin to the -1 up there, okay? You go, you're wondering what those buttons were for on your calculator, right? So you go second sin, okay, of 5 over 6. 5 divided by 6, okay? And then I hit enter, and I get that this angle theta is about equal to 56.44 degrees. Okay? Make sure you're in degree mode. If you don't get that angle, you're either doing something wrong or you're in radian mode. Okay? I'll help you if you can't figure out how to change mode. So you just do second. That's where you do second. That's called the inverse sign. Inverse sign of 5 over 6, okay, is about equal to 56.4 degrees. So if I know this ratio, I can figure out that angle. And back in the olden days, we used to have to look in the book and look for, you'd have to figure out, okay, 5 over 6, that's like 0.8 something. And you'd have to go to your trig tables, and you'd look up a bunch of numbers and say, oh, that's closest to 56 point something degrees, and you'd have to kind of do it analytically. But now you have calculators that do that all for you, okay? We're going to try one more, and then we'll be done, okay? And then you can have some time to try, okay? So let's do another triangle. Here's another right triangle. Let's say that this side, here's my right angle. Let's say we want to know this angle theta over here, and that this side is 11, and this side is 13. Okay? Find theta. Find theta to the nearest tenth. Which trig function am I going to use? If you don't believe me, we're just going to go second cosine of 11 over 13. And boom, about 32.2. How could I find this thing? How could I find this side over there? How can I find that side? Trevor? Yeah, so you could use trig again. You could say that the sine of 32.2 is equal to x over 13, right? Or you could just use more accurate as Pythagorean theorem. So you can find out, how could I find this angle over here? If I know that this is 32 point, that doesn't look like 32.2. If I know that this angle is 32.2, how could I find this angle?
Subtract it off 180.
Subtract it off from, well, yeah, that this and this are complementary, right? So 90 minus 32.2 would give me this angle over here. Yeah? Okay? Any more questions? You think you could do this?
Yes.
Okay. So, so this is kind of introduction to right triangle trig. Your homework is page 644. 644, 1 through 20. Okay? All. And on the Schoology, I say you don't need to draw the pictures, but you do need to set up the equation for every problem. So like I did right there, you need to at least show this and probably show this. I don't care if you draw the picture, but you need to set up the problem. Okay? You got some time to